Record. Right. So an official good afternoon again. Welcome to the NEBOSH Process Safety Management course, level 4. And we are on chapter 3. I have my books here with me. We are on chapter 3 today. Really the easier part of chapter 3. I do believe last week was a harder part of chapter 3, right? Looking at what is from the start of it, safe operating envelopes, then we had performance standards, safety critical element, then performance, not performance, but the characteristics of a performance standard. I don't know if anybody remember that. Like, what are the characteristics of, well, really a safety critical element that performs the performance standard. And that would have been remembered by the acronym FASI, FARSI, which meant then that the safety critical element had to be functional when needed. It had to be available, reliable, survivable, and interdependent, right? So just as a note here, I know just a few of us here, but for those who are looking at it, I guess this on the class group chat, please remember that whenever you're doing something, put your best foot forward in it and try to do some studies, right? Remember, this is not an open book exam. This one is an exam itself, right? So you have your book. I have mine. Try to run through the slides, run through the video, make notes in class, study your work, right? There is really no way I think anybody can predict an entire paper. We have done so, like for the different NEBOSH courses, certificate, diploma, environmental, but in no way has any prediction been 100%. I mean, that is not possible, especially when the exams are set in the UK, right? So whenever we slow down for a question, that doesn't mean that's a guaranteed question. That just means that that's a trend analysis in terms of the questions itself, right? With that said, let's start. If you have your books, this is 3.4, so you can get it open there. The use of steam within process industries. From here it gets easier, right? From here it gets easier in terms of the knowledge itself. The rest of chapter 3 is a bunch of small topics, and really a bunch about maybe about 5 or 6 smaller topics, right? So the thing though, it doesn't matter if it's a smaller concept or something from last week in terms of CT critical element, all have a question on them, right? So we'll try to kind of slow down to mention the past paper. Please remember the past paper is not 100% guarantee, or past questions is not 100% guarantee of future questions, right? So don't ever say, well, you could say what you want to say, but don't ever say that we said that this was coming and it didn't come, because I've never said that. I've always said past papers, right? Past papers doesn't mean future papers, right? We can just do what we could do, which is to suggest that something is a past paper question. That doesn't mean it's going to be a future question, right? We can just do what we can do as teachers, which is to let you know what is common. But you as a learner, you should learn everything. You should study everything. You should read everything, right? And not sort of depend on what a trend analysis is anyway, right? Before I officially start, let me see here. All right, still missing a lot of people inside. But I just want to shout out just a couple of folks. So results for the NEBOSH level 3 did come out, I think, on Friday night. I don't have it in front of me because I'm home, but I am aware that a number of you have passed your exams. And I suppose so in one way or the other, right? I know Carrie and stuff would have been in our class before. So I know Carrie and Paz would have been before, right? But I'm talking about the last batch of students. We had I know some of you all here, so I'm going to shout your names anyway. If it's anything you pass, one of the things I learned with the UK is that the mentality is different, right? The mentality is different. And you all know that. You know that in the course, Nibosh is different from anything else that you would have done. And the mentality they have, is anything you pass then, anything you pass in this sort of qualification, you could congratulate yourself on it. It's something that is noteworthy then, right? So for those who pass one, those who pass two, it's all commendable. And that's why, some of you all talk, well, we talk as we talk in the Caribbean, but they don't really talk in that in certain parts of the world, right? So like you would say that, well, well, somebody would say like they fail, but there's no such thing as fail, right? That's why your grade step doesn't say fail, it says refill. Refill just means you have to do it over again. And I guess that's part of life. I mean, we tend to think differently in the Caribbean here, and I guess South America as well, but there's no such thing as fail. Failing is just a way of learning, right? That's actually the best way to learn, but it's not really fail, it's actually just referred to the next time. So do it over. Who have to do it over? And I know many of you here, I was going to shout the name like Adisa and Shakti, right? Those who would have done the latest exam, you would have passed the NIBOS certificate. So congratulations there. And of course, we have students who, would have gotten passes before, like Wahida. Wahida has been here before. She'd have gotten her certificate way before, right? Pooja also was in a previous batch and she got a full certificate. So it doesn't matter, and that's something about life. I mean, if you all think about it a bit, you learn more sometimes, well, not something, but you learn more when you have to do something again, right? I'm trying to find another way to say it. But like I say, it's not the way that the Caribbean mind thinks about things. When I was in the UK, I actually saw that whenever somebody passed a NIBOSH qualification, you would be congratulated. It didn't matter if it was one or two, didn't matter if you passed at 45 or 75, it didn't matter, right? The developed countries think different to us. We think a kind of colonial kind of way anyway, but they don't think like that. And I said that's why some things on their grade slip doesn't say how we talk in the Caribbean here, right? So once you pass, you feel, I mean, you should feel proud because it's something worthwhile. It's nothing that is not worthwhile and it's nothing that is local. When you pass, you should feel a sense of accomplishment. And if those who got all, congratulations. And those who didn't get all, congratulations still, because you would still have a chance to get it. Again, there's no such thing as failure, or there's no failure is not the end unless if you're dead, right? Once you're living and you have breath and you can move forward, well then move forward, right? But the good news here is that many of you here, look how much names I call, had full passes, right? So congratulations, folks. Well done. I think just to be honest, the class that you all were in, I'm talking to the class with uh, the class that got results Friday. Actually, you all got the highest in the region, right? So, we normally say the Guyanese, and I have some Guyanese folks here, right? But we normally say the Guyanese students would have gotten the highest, but not this time, right? We had some Trinidadians that got very high, in the 70s, right? So I think for now, for that sitting, Trinidad would have kind of, I mean, it's one school, it's Shadrach Safety Institute. Doesn't matter if it's Guyanese or Trinidadians or Grenadians to me. But I'm just saying that for some people, we have said Guyanese would have gotten the best of us. But this time around, right, that class had I have two students in the class that got like the highest mark in the region. So we know that it is capable and you all are capable of doing it. And again, this one as well, right? So congrats to those who got one or two units. It is something worthwhile. I have learned that from the UK. And also those of us who are in this one, again, please put your best foot forward because these things are certification for life. Once you have them for your betterment, for your generation, for your future and for your growth then, right? Nothing here you have to do over anyway. With that said, I have realized a lot of the cameras are off. Just that's okay. Remember, just after lunch is a Sunday, that's okay. But remember, when you could turn it on and off, you could turn it on and off because remember the sessions are recorded on Play Stuff Nibosh have a way of looking at it as well. So you could often toggle it back and forth. It's Sunday, it's after lunch, but this is when we could achieve this qualification anyway, right? Let me make a start now. Right? What I'll do, like I said, this chapter 3 now is just a bunch of small topics and explanation, right? So if we could read a bit like how we did last week, explain, focus on the question. Get our next one, our next subtopic, read, explain, question, right? And use that pattern and see how far we can go. I do believe next week we'll be starting chapter 4, and chapter 4 is the last chapter. That's how simple it is, right? So you probably have 2 more sessions after this one, and then we'll see how it goes. We'll see what you all want and stuff, and your exam may end up being in August then, because in 2 weeks again will be, the end of July, right? So the exam may end up being the last week in August is when the process exam is on a Wednesday. And remember, you have a whole day, but when you log in, you have an hour and a half to finish 40 questions, right? And for you all, you have to get 24 correct, which would equate to 60% for you to pass the process safety level 4 qualification, right? Let's make a start. Sorry for all of the information there, but we have to say it, right? So we're looking at STEAM. Let me just run through the slide first to kind of get something behind us, and we'll look back at the book a bit, right? And we'll look at the book. I'm actually on page 72, 73 already. So STEAM, the heading here is the uses of steam within the process industries. Steam is a principal energy source for chemical industrial processes. It provides energy for process heating, pressure control, mechanical drives, and component separation, and is also a source of water for many industrial operations and chemical reactions. The popularity of steam as an energy source stems from its many advantages, which include low toxicity. Remember, it's steam, right? It's water that you heat. Transportability, high efficiency, high heat capacity, and low production costs relative to other energy transport mediums. Um, Nothing there for exam as yet, right? So reading on. The ability of steam to retain a significant amount of energy on a unit mass basis between 1,000 and 1,250 BTUs per pound makes it ideal for use as an energy transport medium. Energy can be extracted from the steam in the form of mechanical work through a turbine or as heat for process heating. Since most of the heat contained in steam is in the form of latent heat, that means hidden heat, large quantities of energy can be transferred efficiently at a constant temperature, which is usually attribute in many process heating applications. Steam is also used in contact applications such as the reforming of natural gas for nitrogen fertilizer production. Process steam systems are used to control the pressure and temperature of many chemical processes, and in applications such as stripping of contaminants, facilitating fractionation of hydrocarbons, and in certain drying processes or operation. A process steam system consists of 4 categories listed below: the generation of steam, the distribution of steam, the end use of steam, and the recovery of steam. Steam is normally generated in a boiler or waste heat recovery device by transferring heat from hot combustible gases or other hot process steams to water. The water absorbs the heat, facilitating the phase change necessary to produce steam. The steam is then transferred under pressure from the boiler to the distribution system. In general, 2 types of boilers are used to generate steam. Steam is normally generated in a boiler or waste heat recovery device by transferring heat from hot combustible gases or other hot process steams to water. The water absorbs the heat, facilitating the phase change. I think this is the same thing from the last slide, right? The most common operational end use of steams include stripping of contaminants, fractionation, this is the use of steam, power generation, mechanical drives, process heating, quenching, dilution, for example, of oil. They use steam a lot in the oil industry. Vacuum draw, if they want to clean a tank, steam can be used for that. Pressure regulation, injection into like wells and oil wells, source of processed water. Okay, so none of that is exam, right? So I'll tell you to read and get to the exam question. So the exam question is this. If you have your book, page 72, so okay, steam is good and whatever have you, right? Steam is used. It's just water that you heat up and stuff, right? So what I'll do if you want to watch the slide or watch your book, if you watch the book, you're gonna see like it have two kinds of steam, and it's on the slide here too: saturated and superheated. Saturated and superheated. There are two types of steam, right? And so what they like to ask is like, what's the difference in them? Or they may ask you at what temperature one is and what temperature is the other one at, right? So to make life simple for you, before I read, I'll just explain it out to you, and then we'll read a little bit, right? So if you have made tea or boiled water or I guess, cooked food, which we all have done, and you sort of lift up your pot cover, you would realize like it will have steam, but it have water droplets as well, right? Now, that type of steam is called saturated steam. Again, this is exam, right? So I tried the best to break it down the simplest way. So saturated steam is the steam you have in your kitchen. Saturated steam then is the one at 100 degrees Celsius because water boils at 100 degrees Celsius. So if you would boil water and then you take off your, like your kettle or even the kettle or the pot cover if you're boiling it in a pot, you would see steam, right? And then you would see water, right? That's called saturated steam. Saturated steam is where you have steam and water together. If you watch the note here, it's where steam and water can coexist, right? All of these big words is where the rate of vaporization is equal to the rate of condensation. I don't think they'll get into that, but saturated steam is the one at 100 degrees Celsius. Saturated steam, it's easy to produce. It's just water. You heat it anyway, right? 100 degrees Celsius or 212 Fahrenheit. That's saturated steam. Saturated steam, because it have water in it, may contain water droplets, and that may create, things like rust. There's a bacteria that tends to love to live in hot water runoff. So saturated steam may cause corrosion because it have water in it, right? Saturated steam, if you want to write anything down, I've said it like two times already. Saturated steam have water in it, contains small droplets of water. Well, of course, when you're studying, right, you have to study your work, right? You can't just wait on me anyway to kind of pinpoint anything for you. But you read your notes and you know that this is a trending topic then, right? So saturated steam have water in it. And some people refer to it as wet steam because it have water in it. Saturated steam is sometimes called wet steam. So before we go to the book, I was going to the book, but before I go to the book, I'll just do the other one time. Superheated steam now is steam that is above 100 degrees Celsius, right? And so like how you could create superheated steam, you can actually create superheated steam in your kitchen, but you have to get like a blowtorch, right? So like the same pot that you were heating in the stove, you have to apply more fire to it then, right? Like the burner would only produce so much of fire, which would carry it 100 degrees Celsius. But if you want to superheat that vessel then, that pot, you have to probably there's some kitchen blowtorch, right? Chefs around the world normally use them. So if you have like two kitchen blowtorch, you can actually apply that to your pot. And what's going to happen if you're taking any notes, what's going to happen? If you start to superheat your already existing vessel with water in it, what's going to happen? The steam is going to disappear. The emissions from the pot, like when you're boiling water, you'll see steam, but saturated steam would be invisible. So saturated steam is above the boiling point, and you have to exceed the temperature. You have to exceed 100 degrees Celsius for my mistake, for superheated steam, right? So for superheated steam, you want to go above 100 degrees Celsius. And when you do that, you're going to apply some additional flame here. The steam will become invisible. Right? Superheated steam is actually better than saturated steam because it does not have any water in it, but it have a hazard in it. The hazard is that you cannot see it, right? They use it a lot in the oil industry. If you all have gone through certain parts of Point Lisa's, Santa Flora, you have steam lines. Normally, a oil well, they pump steam into it to kind of get the oil moving there, right? So superheated steam is steam, if you've taken any notes, is steam that is invisible and it doesn't have any water in it, right? So superheated steam is not wet, right? Superheated steam is actually not wet. It does not contain any water. In fact, you can't even see superheated steam, which is a hazard, right? The superheated steam, if somebody didn't know, like this is a steam line here. Now, you will know in the companies, right? Like if this is a line, if that's the end of a line, right? I just section it off here, right? So if that's a line that was producing steam, you should know. Now, if you wonder how you should know, the companies does wrap something on it. Anybody ever saw it? It have like a shiny material that's wrapped on this, right? It wouldn't be like that, of course, but it's wrapped. It's wrapped around the line. It's a silver material containing an asbestos material. So if you're driving anywhere, Point Forte, and I've seen it, Santa Fe, I've seen it, Point Vista, so I've seen it. If you're driving anywhere and you see like a line, like a oil line, but it have a silver wrapping on it, right? That's a steam line, right? So if that line was somewhat broken, what I'm saying is that you need to be careful because that it's gonna have steam there, but you mightn't be able to see it, right? And that steam is very hot. It's good. It could burn you. It would, of course, burn you. It could actually cause fires and stuff, right? Superheated steam is very dangerous. Like you wouldn't see it. It's not like the one in your kitchen, right? When you heat above 100, you take off the water then. So you cannot see the water vapor, right? But if by some chance I'm saying you are in any company and you see a line that has a silver wrapping on it, don't go close to that. That's a steam line. And if it's broken, you mightn't be able to see because steam is invisible. This superheated steam is invisible and it's more dangerous than the superheated steam. I mean, sorry, not the superheated, the saturated steam in the kitchen, right? The saturated steam is bad enough that could burn you, but this one is superheated over 100 degrees Celsius, right? Let's take a look at your book a bit. That's it there for the two types of steam now. If you have the book page 72, now these things kind of slow me down, but these things are sometimes worth it anyway, right? Page 72, the right-hand side, but still on page 72, right? Not 73, page 72, the right-hand side. They say one of the problems with saturated steam is that it is still wet. So we know that saturated steam is the one with the water in it, right? If you jot down a bit here, uh, if saturated steam is heated further, the second paragraph, it turns into superheated steam that is effectively a gas. The superheated steam has a temperature higher than its boiling point, which is more than 100 degrees Celsius, right? And if you come down a bit, you'll see superheated steam is an invisible gas, right? And not readily detected by the naked eye. So therefore, like I said, one of the ways to detect it is the companies, if something is a steam line, they would have wrapped a silver, they call it a lagging, Lagging. They would have wrapped the line with a silver material, and that's to kind of insulate it a bit, right? And so you think you're okay with that? Just take a look at that. And they do have questions on that in every sitting anyway. Um, most times, and they tell you like, well, which is which one? So which one is superheated? Which one is saturated? There may be a question here. So we can take a look at it, right? This is the many uses of superheated steam. This is the one with all the water now, right? This when you heat the steam, it's very good for cleaning because it doesn't wet anything, right? Soil steaming, energy system, nanotechnology to clean out those little computer bits and stuff because it's not wet. It's going to sanitize, it's going to sterilize. So superheated steam is very good for, cleaning and, whatever have you in the chemical industry, right? Let me see if I could find the question. Some of the hazards of steam, thermal expansion, formation of vacuums, water in the steam line, and this will be talking about which type of steam. If you have water in the steam line, like what type of steam is that?
Saturated.
Saturated, very good, right? So let me see how to break this one down for you. I don't think there's a question there, but I guess this is if you happen to work in the industry, and you don't have to, I just saying, right? But if you are home, and those of us in Trinidad and I guess in Guyana, if your water company has put on the water then under the excessive pressure, you'll actually hear the water in the line is going to create a sound, right? So in the oil industry, that's very common. In the oil industry, the lines in them, when the lines in them are on, when they're pumping oil through the line, you have to hear it. It vibrates then, right? So that's something called a water hammer. And that could actually result in the pipe bursting and whatever have you, right? So water in steam lines, water hammer is the unexpected release and associated shock wave of high pressure steam condensate that can cause death, severe injury, or extensive property damage, as if the line is broken because of the pressure of the fluid in the line, right? Some hazards of steam could be scalding, serious physical injury, and I guess that's probably, let's see if we can find a question on steam, right? So, or did I pass it? I think I passed it. It have more than one though, but look at have a question here, right? It comes in every setting. Now, it don't have to be saturated. It could be superheated. Just remember, you just have to keep on heating the steam for it to be superheated, right? So what is saturated steam? This is from a past paper. They have where all the water has been converted to steam, saturated steam, right? If you want, this you could think of SpongeBob, a sponge, saturated, right? A sponge, where some water is still retained in the steam under very high pressure. The question is on saturated steam, which is the one in your kitchen. Steam at a temperature in excess of 200 degrees Celsius, right? Which one do you think is the best answer here? And I'll tell you why the others are wrong. Saturated steam is one with what? I got one answer on the chat. Okay, B, thanks there, Shakti. That is actually, let me wait until the rest of them say something. Which one is saturated steam? Where all the water has been converted to steam. Look at here. Saturated steam is actually called wet steam. So where all the water has been converted, and that's not saturated, that's actually superheated. So A is wrong. Saturated steam is not under any high pressure because as the one in your kitchen, you can just boil water and you create saturated steam. And the boiling point of water is 100 degrees Celsius, so this is actually wrong. So the best answer here is actually Shakti's answer, which is actually B. Thanks there, Kamini, as well, right? So those two answers are correct. So once you learn your work, you cannot go wrong. Nibosh is not hard, but you have to learn your work. And again, I teach a bit funny because some teachers don't teach like me, you just teach. But I would pause and tell you, look, there's a past paper here, look, there's this here. Again, please remember that doesn't mean that it's 100% guarantee. It's just a past paper, but they tend to repeat. So, we have to do what we have to do. All right, so that's it there for this one. The main thing you have to know there is what's the difference between saturated steam and superheated steam. It comes in every paper. I have opened the book. It's on page 72. I read one or two lines so that you can highlight if you wanted to. The first paragraph on page 72, the end of it, the end of the first paragraph says, saturated steam is sometimes known as wet steam. You can underline that if you want. I guess by extension, we can say superheated steam is then known as dry steam because it have no water in it. In fact, you don't even see it, right? All right, I'm moving on. I think the topic changed a little bit, right? There's a little change of topic there. I think what they have gone into, if you look at page 73, is now no, not page 73, page 74 is now water hazards, right? So it's not really steam, but it's just good old-fashioned water hazards now, right? And of course, steam could condensate and it could get water out of that, right? So that's what they are making mention of here, right? All right, let's go again. So water hazard. So if you want, I'll read again because there is a passive here or two. Let's read them out and then I'll tie the pacifier, right? So water hazards and associated controls. So vacuum formation during the draining operation, right? Hydrostatic testing or weight testing. A hydrostatic test is a way in which pressure vessels such as pipelines, plumbing, gas cylinders, boilers, fuel tanks can be tested for its strengths and for leaks. The test involves filling the vessel or pipe system with liquid, usually water, which can be dyed to aid in a visual leak detection and pressurization of the vessel to the specified test pressure. Um, there's a question right there, right? I mean, so um, if any new vessel would have been created or welded, they normally hydrostatic test it, right? What is hydrostatic testing? They fill it with water and they let it stay to see if the tank can hold the water, right? If anyone is familiar, there was a accident with this, with Trinma, where they fill a tank, but the tank couldn't hold the pressure and the tank burst. This is in Point Fortin, kind of on the radiator Claxton Bay, and was a huge tank and it resulted in a huge flood, right? It resulted in like when it had flood in South Trinidad because it's a huge tank, right? But at least it was water as opposed to maybe oil or fuel or whatever have you, right? So that's something that they do. It's called hydrostatic testing as a way to test a tank for a leak. Please take a note of that. And we can move on because this is a question, right? What is hydrostatic testing? That has come before for exam. If you look at the book, page 75, there's another kind of hazard there. Let me read it out first and then I'll explain it. So coolant tower area heat rejection devices that reject waste heat in the atmosphere through the cooling of a water steam to a lower temperature. Typical hazards can include Legionella and water fog. So just when you're cooling down steam, right? Remember the water runoff is going to be kind of warm. And what I was saying, they have a bacteria that loves to live in that. We have had some deaths in Trinidad. I'm not too sure if around the world. Well, when I mean like Guyana, though, right? In terms of legionellosis. So legionellosis is a collective term for diseases caused by the Legionnaire bacteria, including the most serious Legionnaire's disease. Outbreak of the illness occur from exposure to the Legionella growing in purpose-built systems like a condenser, something that have to cool down steam then, right? Where water is maintained at a temperature high enough to encourage the growth. Example, cooling towers, evaporative condensers, hot and cold water systems. Anyway, I used to be working all around all of those things and I never even know that. I mean, like when I used to be working, all right, in the industries, I never knew that. I used to be working all around those condensers and literally where the water was where I used to be. They'd like the water run off then, right? Anyway, water hazards and associated controls. So certain conditions increase the risk of Legionella if the water temperature in all or some parts of the systems are between 20 to 55 degrees Celsius. A pause because you have to know that. I don't know if you want to see if you could find it in your book, you page 75, or you could just take it in the notes. It's the same thing. That's where the bacteria like to live there, like where the temperature is between 20 and 55, right? It is possible for breathable water droplets to be created and dispersed. Example, aerosols created by a coolant tower or water outlets. Water is stored and or recirculated. If you could get those places where you have those warmer waters being recirculated, and the bacteria is in that, what they're saying, you can actually breathe in the bacteria, if you can breathe in the water droplets, right? So where we have water systems that the temperature is maintained at 20 to 55 degrees Celsius, it could result in a bacteria growing there, and the bacteria results in a condition known as legionellosis or Legionnaire's disease. Now, let me see if it's on this slide, right? Okay, if it's not on this slide, let me tell you. So Legionnaire's disease, the symptoms is like the flu, is like COVID-19 then, right? Legionnaire's disease is the symptoms is the same as the flu, right? And why I mentioned COVID-19 is not because I want to talk about it, it's because it affects the lungs, right? Legionnaire's disease affects the lungs. Some, diseases, God forbid any one of them, right? Affects different organs of the body then, right? Like dengue doesn't affect your lungs. Dengue affects the blood, right? The platelets, your blood, but like when the blood is made then, right? Platelets is a blood protein. But COVID-19, what made it worse or what made it bad for those who got it? And for some people, it resulted in pneumonia because it affected the lungs, right? So the same with Legionnaire's disease. So the point is of this story is that you could die, right? Remember, well, I guess you could die from many things, right? But if a disease doesn't affect your vital organs, then you could probably live a bit, right? For those of us who remember, anybody remember chikungunya here? Chikungunya, that particular disease that went around. The year was about 2015, right? Chikungunya didn't affect your lungs, nor did it affect your blood. It affected your bone. Now, it wouldn't have caused any death. It caused a lot of pain, right? Chikungunya caused a lot of pain because it affected your bones, right? But COVID-19 affects the lungs and Legionella also affects the lungs, right? So it could result in pneumonia. So there's deaths coming out of this particular disease then, right? Anyway, back to the exam question. The exam question normally is around this temperature here. They normally ask, what is the best temperature or what is the temperature range for the Legionnaire bacteria to grow, right? Resulting in Legionellosis. They might even say Legionellosis, they may say like water systems or water cooling systems may give rise to certain diseases. At what temperature would the bacteria, even if they say bacteria, but at what temperature would it be suitable then for the disease to occur? In this case, the bacteria to grow, in fact, right? But I don't know how they phrase the question. But what you're looking at is between 20 to 55 degrees Celsius, right? Now, folks, I think there are two questions here, but I'm going to make three out of it. I think there's one there, right? But I'll make three out of it because there's another tricky one I saw. And I wanted to probably give you opinion on that answer as well, right? So this one here, what is hydrostatic testing? A, it means to test the water quality to be used in a process. B, it means to ensure the equipment is safe and would not leak. It means to ensure the supply of cooling water. D, it means to ensure that there are no blockages within the pipework. What is the purpose of hydrostatic testing? Why do we fill the tanks with water before we actually fill it with oil? What's the purpose in it? Which is the best answer?
The B.
B, right? So very good. Just take it down. B, please remember, any paper you see, take it. Any paper you see, take it. Right? I did send some past papers to you all this week, right? I know you probably had a busy week and you didn't get a chance to look at it, right? Yeah, I did email some past papers to you all this week, right? I had a couple of students that give it a try. Please remember, this is not an exam, it's just a past paper. So when you get a chance, give it a try, send it in to me. When I get some time, I'll correct it. I got one Friday, I corrected it same time. You don't have to get everything correct, right? But give it a try. If you want to, write on the exam or circle it and whatever, send it for me. I'll put in the correct answers for you. But try to give it a try, right? Don't let because I mean next week is chapter 4, right? So we kind of coming to the end anyway. And so the participles are important, right? So B for this one. Let's take a look at this one. Well, I kind of highlight the answer for it, right? Legionella bacteria grow at temperatures between -10 and -5. 20 and 55. Remember, you have to learn a bit for the exam. So you have to learn this. You are seeing it. I've said it and you are seeing it. 60 to 70, 70 to 100, right? All right. So listen to this one, right? So that's the end there for steam and water and stuff, right? And we came across quite a lot of questions. What is saturated steam? What is superheated steam? What is hydrostatic testing? What is the condition needed for Legionella to develop, right? And we know how serious Legionella is. If this is not treated, the person will die. And I told you before, I know of some deaths of this in vessels here in Trinidad as well, right? All right, listen to this one though. I don't know if you want to paraphrase one for me. When I say paraphrase, I'm going to write it on the slide. Okay, so very good for those who took part. I had Shakti there again. Let me just check on the chat, but the thing seems to be frozen. Let me see what's happened. Okay, okay, good. I don't think it moves anymore from that. All right, so there's another question I saw, and I wanted to take this down. So we can take it to be the same question. Legionella bacteria grow at temperatures between, but another question went like this, right? The question went like this, right? So the A, well, 20 degrees. By the way, I'm making up these, but I remember some of the numbers then, right? So, like, what do you put now if they give you something like that, right? These are some of the numbers I saw on that past paper. So is it well, it's A, B, C, D, right? And this one had students confused to the max. So we could take the same question. Legionella bacteria grow at temperatures between 20 degrees, but that's correct. 55 degrees, that's correct. 37 degrees, that may be correct for the because they're all in the range, right? So which one is correct now?
Seafood, 37 degrees.
Say,
So yeah, what do you see?
okay, C. Why you say C?
But I the temperature, the body temperature.
Very good, right? So that's excellent, right? So the answer is C, though. This is actually in the textbook, right? So for those of us who know, viruses, bacteria, they live a happy life, you know. Remember, they are living organisms, right? Well, a bacteria has a cell structure, right? Human beings have a cell structure, but the thing is, like, we can't coexist then, right? And whenever they get inside of us, that's when you get sick, right? They make us sick. Viruses and bacteria make us sick. But remember, those are organisms. And in some cases, a cell, right? And the human body is at 37 degrees Celsius. And it just happens to be that that's like the ideal temperature. If you say between 20 and 55, the ideal is actually 37 for these things. And it just so happens that that's our body temperature, right? So the ideal temperature is 37. Even if the range is 20 to 55, the ideal is 37. That's our body internal temperature. If you check the book, you'll see it. You can probably underline it. I did it there for you, right? But you know, some of you like to see it in your book. On page 75, left-hand side, in Cooling Towers, the first paragraph, the last couple of sentences, right? They say the ideal growth temperature for the bacteria is 37 degrees Celsius. It just so happens that the human body temperature and hence the risk, as well as causing pneumonia. So you heard me mention that, right? The bacteria could also cause a fever, Pontiac fever, that is generally less serious, which is good. If you get a less serious one, great, we could recover. But if you get the pneumonia and your lungs get infected, that is sad because, you know, I don't know if you know what have to happen. I don't even want to describe it, right? But if you had gone through COVID-19 and you had anybody that was so much affected, you know what have to happen, right? You normally have to, the doctors will put the person in a coma, right? Because remember your lungs are where you need to breathe. Once you dissolve oxygen, level goes down, they will induce a coma on you. Some people recover, some people don't recover. I've seen both, right? All right, we moving on, right? So that's it for that. I could clear that slide here. So we finished. Remember, there's a bunch of small topics. In a way, we did two small topics here. We did steam and we did water hazard. So if you want to line up your book, we're going to look at inert gases. There's just one question here. Inert gases, which is Then we're talking about nitrogen. If you want, you can turn the page. Page 76, you'll see just one page. It's just like one page. When you turn out that, you'll see electricity. So there's a lot of small topics here, right? Let me read. I think I read out all or read until it gets boring, and we'll just focus on the question, right? So an inert gas is a gas which does not undergo chemical reaction under a set of given conditions. The noble gases, this is a term from chemistry, often do not react with many substances. Let me admit somebody, right? Inert gases are used generally to avoid unwanted chemical reactions degrading a sample. Purified argon and nitrogen gases are the most commonly used inert gases due to their high natural abundance. 78% of nitrogen is in the air, 1% of argon is in the air at low relative cost. Yes, like the earth have a lot of energy, right? The air that we breathe in have 70% nitrogen. And there are companies that condense that nitrogen then and get it into a liquid, right? So amazing, eh? Because the earth is the atmosphere then is abundant with nitrogen. We are right now breathing in nitrogen gas, but it does nothing to us, right? The air we breathe in have 78% of nitrogen in it. And nitrogen is a fuel source. The sun is also a fuel source, right? So anyway, right. I'm just moving on here. Just get this slide to move. So nitrogen is a colorless, odorless, and tasteless gas that makes up 78.09, about 78.1% by volume of the air we breathe. It is non-flammable and will not support combustion. Nitrogen gas is slightly lighter than air and slightly soluble in water. Nitrogen condenses at its boiling point, which is minus 195.8 degrees Celsius or minus 320.4 Fahrenheit to a colorless liquid that is lighter than water. More nitrogen is used by customers than any other industrial gas. It is used in a broad range of industries, including chemicals, pharmaceuticals, petroleum processing, glass and ceramic manufacture, steel making and other metal refining and fabrication processes, pulp and paper manufacture and healthcare. Aside from nitrogen, N2, nitrogen may be referred to as GAN or GN in its gaseous form, and LIN or LN in its liquid form. I actually saw that in a company in Trinidad. Like before I see it, I didn't think like we used to use that, but Trinidad does produce nitrogen. Remember, we have uh, that capability, right? Massy gas and stuff, right? Does a bunch of that as well, right? So nitrogen is produced in large volumes in both gas and liquid form by cryogenic distillation. Smaller volumes may be produced by a gas, such as a gas by pressure swing absorption or diffusion separation processes, which is permeation through specially designed hollow fibers. Cryogenic processes can produce very pure nitrogen. Uh, Gaseous nitrogen is valued for its inertness. It is commonly used to shield potentially reactive materials from contact with oxygen for safety or for quality control reasons, providing inert atmospheres, purging, blanketing of storage tanks. It is used as a firefighting agent. It is used in pipeline freezing operations. Nitrogen can also be used in certain instruments as a backup supply of air, which they don't want to use oxygen because the oxygen may be a source of fire, right? The inert properties of nitrogen make it a good blanketing gas in many applications. Nitrogen blanketing is used to protect flammable or explosive solids and liquids from contact with air. Certain chemicals, I think we read this already, right? So inerting or padding are other terms used to describe the displacement of air and nitrogen blanketing. All right, oxygen is essential to life and is therefore vital that adequate oxygen is present in any atmosphere being breathed. While a healthy person may survive a short exposure to air with an oxygen content as low as 16 degrees Celsius, no one should ever be asked to endanger his or her life by breathing in such an atmosphere. Oxygen deficiency cannot really be detected by the human senses. Victims are usually unaware of the dangers that they are in and may even have a feeling of well-being. So this is what happens to the human body if you're breathing less oxygen. We should be breathing in 21%, which is what is in the air right around us. About 19.5, you may start to feel dizzy, but at the lower figures, at the lower percentages, you'd see here 6 to 8, fainting within a few minutes. 11 to 16, the person may be, without the person being aware of the, like your reduction in physical and intellectual performance. And below 11%, there's a risk of death, can lead to loss of mental alertness, distortion of judgment, brain damage after a relatively short period of time. Um, okay, one last slide. Asphyxiation, the effects on the body of inadequate oxygen, usually resulted in loss of consciousness and or death. This is known as suffocation or anoxia. It is absolutely essential to understand that with this inert gas, such as nitrogen, argon, helium, asphyxia is insidious, meaning there is no warning signs. It is to be noted that the use of inert cryogenic liquids such as nitrogen or helium is accompanied by two primary hazards. The liquids are very cold and can cause serious cold burns on contact with the skin. All right, so here the question there, right? The question is the obvious question. The question here is what is the main effect of nitrogen? Like if they use nitrogen for cleaning like a tank or to ventilate the tank then, right? Or to inert the tank. They use it in Atlantic LNG a lot. Wherever they use the nitrogen then, right? What you have to know is that, let me just write something here first so that you see clearly that sometimes we see it and you're not picking it up. So I can write the main thing here for you, right? Like if you use nitrogen to purge a tank, if you use nitrogen to purge a tank, you will have 0% oxygen. Zero. Not one, not 16, 0% oxygen. If you use nitrogen to purge a tank, I'll say it again, you will have 0% oxygen. Zero. Right? So if anybody stepped into that vessel, if somebody stepped into a vessel, a tank, a cylinder, wherever it is, when I say tank, it have like underground tanks too then, right? So if you step into it or you get into the doorway here of the tank or the vessel or whatever it is, whatever would have been, purged with nitrogen, right? You will die. That's the simplest way to say it, right? Because it have not 16%, not 11%, it have 0% oxygen, right? So the main hazards of nitrogen for the exam paper is what is the effects of nitrogen, and it could be oxygen deficiency, right? Or death. The answers that kind of go along that way, the hazards of nitrogen, it's good for the tank, to clean the tank, right? But if an operator comes by and that vessel has been purged and enters that tank, enters that pipe, enters that vessel, you will die, right? So I have two stories to tell. I don't know which one to tell, right? So anyway, I'll just choose one, right? So it had an accident with this, with nitrogen, where they had a purge a tank, right? But it wasn't like this. It was, well, this was like an underground kind of thing then, right? So it's like an underground sort of thing. And the operators and them, they went in with their full breathing apparatus, if you listen to the story. And when they came out of it. So this was kind of, like in the compound itself then, right? It was like a manhole that they came out of. But they came out with the CBA and everything, right? They came out, they went in with their breathing apparatus and they were okay, right? They were okay. But here's the thing, right? When they look back, they saw a roll of electrical tape. They saw a roll of electrical tape just right down there, just right within like maybe about 2 feet, 3 feet, right? So it was like within, like you could have taken, I think one person said that what they would have done, they'd have taken a piece of wire and made a hook. So instead of re-entering the vessel, in which you have to issue a permit and stuff, right? They'd have just made a hook and they would have tried to hook the tape and to get the tape out now, right? And that's what happened, right? So somebody attempted to hook the tape with a piece of wire, and the person kind of sat down here. When they sat down in the edge of it, right? But they got asphyxiated then, right? Because remember here is nitrogen, right? And they entered the vessel a bit, they kind of sat down, their feet was inside of it, right? And they got asphyxiated and they fainted inside of the vessel. Not too far down, right? Not right down. They were different like levels or whatever. It's not really a tank, it's just like a process sort of manhole, right? And there were stairs to go down. The whole watch. So what happened? And because it was a short distance down, which is about 3 feet, the whole watch jumped into this place here to rescue the person. And that person was also overcome. Right? And then I think the manager or one of the supervisors saw what happened to the two guys were down there now, just kind of went down to the third person went down to kind of get them because they were just there. They were just within reach, right? And about 3 persons died in that incident there because of what I told you. When you purge with nitrogen, you have zero oxygen, right? I could tell you the other story too because it has to do, well, I'll make it short, right? There was one in Trinidad here where I won't tell you all of it, right? Where somebody I knew, his name was Terrence, his name is Terrence. They had purged a tank at Atlantic LNG, which is a big gas company here in Trinidad or on the island. And Terrence had stopped an Atlantic safety. So Terrence is like a contractor safety, right? He was with a contracting company. Those of us in Trinidad, you would know the company if I call it. It's called CX, right? So Terrence was with CX. And he, knowing a tank was purged then, an Atlantic, which is like the staff then, was going close to that vessel. And Terrence actually stopped the person, right? And the end of the story is that for those of us who heard me say this story before, the Atlantic Energy Company, what they did, they rewarded Terrence, right? They rewarded him for stopping the unsafe, well, this staff member from getting close to the vessel or into the vessel. I'm not too sure. This is a 10-year-old story, so some of the details I've forgotten, right? But I remember though that the company um rewarded Terrence, right? What they did, they calculated how much money. I'm not too sure there is a value to human life though, but something they did, and what they did, they rewarded Terrence with 100,000 TT dollars, right? So that's two stories I told you about nitrogen, where in one case, 3 people died. That one was not Trinidad, but it was in the Caribbean, right? One of the islands going up anyway, right? And the other one was right here in Trinidad, where somebody sort of stopped a staff member from going into or around the vessel that was purged with nitrogen. And because it's 0% oxygen, you wouldn't know what happened then. You will just die, right? While I was in Guyana, because I have some Guyanese folks here. While I was in Guyana, about 2 Sundays ago, or 3 Sundays ago, when I landed, there was a case of, I guess, some people who were stuck, right? I guess they went out in the, how do you call it? I guess you could help me say the proper terms then, right? But they went out like into the rural parts then, right? Like if but other people do that, right? So they go like on a trail, right? They go on a trail with their vehicles and stuff, and it got stuck in the mud. And a long story short, they left the vehicle running because it had kids and stuff in the vehicle, and I think they said the vehicle sank into the mud. Because that's where it got stuck, and the exhaust fumes came back in the vehicle, and the occupants of the vehicle there, right, fell asleep, and of course they got asphyxiated and they died, right? And so that's not nitrogen, that's actually carbon dioxide, but it's the same idea that it does replace the oxygen. And in those cases, death is often the result of that anyway, right? All right, I'm taking this off. Nitrogen is actually finished. If you're okay with that, see if you have any questions. Nitrogen is done. The main hazard there being oxygen deficiency. And if they give you a chance, if they pass it, but have debt and stuff in it, that will be the best sort of answer anyway, right? Tell me what you think. It's 2 o'clock. We can turn the page a bit. We are on to electricity. So I'll see if I can do two more and we'll stop. Electricity I'll do, and I'll probably do dangerous substances and I'll stop because by that time we have us two anyway, right? But what I'm saying, we almost finished chapter 3, which means most likely next week is the start of chapter 4. We mightn't get, actually chapter 4 is very short. Chapter 4 is very short, right? So when I say we might get far, that's the thing. Chapter 4 is short, right? All right. So electricity, you all okay? You all alive still? You all with me still? We can sleep in. Yeah, I know it's a difficult time, but if you take part in this, go a bit, it'll be less stressful if you take part in it, right? All right. So electricity, let's get to this. But I try not to overdo it, right? I try because remember there's a lot of notes, but then there's just like 1 or 2 questions, right? So we can try to focus on that. So electricity, we have some definitions of electricity here. What is electric current? The amount of charge flowing through a conductor at any given time. Electric current is measured in amperes. This is another word for voltage. It's called potential difference. The greater the potential difference across an electrical conductor, the greater the electrical pressure that influences the flow of charge through the conductor. Electrical pressure is known as the voltage, right? So the greater the voltage, the greater the current. The greater the voltage, the greater the current. Think about the sockets you have home. If you have a washing machine, if you have an AC unit, maybe that's plugged onto 220. But everything else is like 110, right? So the greater the voltage, the greater the current. Really don't have any questions there. It may have one, eh? There's what is known as resistance. Resistance is measured in ohms. And there is a formula linking those three terms together, right? The current, the voltage, and the resistance. The formula is V is equal to IR. Um, to be honest, I've never seen it, but I think it's a nice question. V is equal to IR. What's the relationship between voltage, current, and resistance? V is equal to IR, right? So you can probably learn that anyway. The other thing here is that you have two types of currents in the world. I kind of come on up this slide, right? I'll explain something here for exam. And this is kind of famous. You have what is called real current. You have what is called real current, and you have what is called conventional current. You have real current, and you have conventional current. Take this one down, and that's where we're writing. This one is a past paper. Otherwise, I wouldn't be writing it, right? So there are two types of current in the world of science. Then you have real current and you have conventional. This is N here, NaL current. And they like this. They like to ask you which is which, right? So if you look at your book, or I may have to go forward a bit again, current flows then, right? I mean, if you have a battery, you have your phone, current flows then, right? Electrons flow, right? And they normally flow. If you track this basic circuit diagram, I don't know if you remember this, a lot of this may have been taught way back when in high school or secondary school. The short line is meant to say negative, and the longer line is positive. You have one in your book, so you don't have to take it down. You have one in the book. Page 78. You can just follow if you want, right? So current is normally, if you look at how the arrow is going, right? Current normally flows from a negative. If you look at this arrow, it normally flows from a negative to a positive, right? And this is called real current. So real current is from a negative to a positive, right? Real current flows from a negative to a positive. Um, so just in case you're kind of confused, real current is how current is found to be in nature then, right? This is when the scientists look at the flow of electrons. electrons are said to flow from a negative to a positive. You're following? All right. So then what is conventional current then? If that's how they define it in nature, what is conventional current? Well, that one is a story, right? But I won't tell you the whole story. So that one is having discovered that current flows from a negative to a positive. Scientists had a convention, they had a meeting, and they said, let's say it flows the other way around. So that's how we have two types of current. Conventional current is not real current. It's just what the scientists and them say. You understand this, folks? It's kind of crazy, right? It's like the theory of evolution, which has been found to be, well, not really, well, parts of evolution is true, right? Which is things do take time to grow and whatever have you, right? And change. But the theory of evolution then in terms of, like where human beings came from is just a theory, right? And so conventional current is just the opposite to how it really is, right? So conventional current, the scientists and them said, let's say it flows from a positive to a negative, but that's not natural. That's just what they said, right? And coming out of that convention, they created this new thing called conventional current. Crazy, yeah? Anyway, I mean, it's not up to me to decide on what was crazy or not. I just telling you what is what. And I just telling you right now, Nibosh like to ask you that. They like to ask you what is real current. They will say under how does the electrons flow in real current? And it's negative to positive. And then another question will say, by convention, how does the electrons flow? And it will be positive to negative. If you have your book, what's page 78, the first paragraph, left-hand side, first paragraph, last couple of lines. Tell me when you find it. Tell me when you find it. This knowledge is kind of needed for physics. It's not really needed for safety, but I just telling you, Nibosh like to test this, right? So that's a way on it, right? All right. The last couple of lines, or on page 78, the first paragraph, they say if you can find the line, or the last couple of it, they said you will have noticed that the poles of a battery are labeled as positive and negative. By convention, current flows from what to what? Tell me what does it flows up? By convention, for those of us in the book, current flows how? Those are the book. By convention, help out those who do have a book. By convention, because people driving and thing, right? By convention, current flows somehow.
Positive to negative.
Okay, but read the next line. But in fact,
The potential.
the electrons flow in the
opposite direction.
Opposite direction. Stranger, but that's for physics. That's something else to talk about, right? Anyway, let's move on because we don't want to spend too long on that. By the way, that is a question. That's where we write it. Huh? So you all make sure you know the difference between real current, look at right there on the slide, and conventional current, right? We can go on to the hazards. They don't have any big questions on hazards. This is the current question right there, right? The next thing in the book is hazards of electricity then, which I have here. Electric shock, electric burns, fires of an electrical origin, electrical arcing, explosions. It may be all of the above. If they ask, where's the hazard of electricity, all of the above, right? All right, electric arcing. An electric arc is a high temperature electrical discharge between two electrodes in close proximity. The energy release is in the form of heat and light. It can pose an ignition hazard. It can result in UV radiation that can cause burns, and in welding operations, the condition known as arc eye. No questions here, so I'm moving on. Electric shock. Passage of a current through the body results in a convulsive shock to the nerves, muscles, and other organs. Shock accidents usually occur when a person makes contact with a live conductor and at the same time as touching an earthed object. Skin has a high electrical resistance, but the body doesn't. Electricity take many parts once passing through the body. Hey, by the way, again, I mean, not in Trinidad now, in Guyana, I think there was a death with this. There was a death when I was there. Somebody got electrocuted I think somebody tried to the person that tried to remove the person also got shocked too, right? I have it on my chat here. I can read it for you. Yeah, the person actually died. The Ministry of Labor, this is Guyana, right? Safety and Health Arch Department has launched an investigation into the fatal accident that occurred just outside SE Auto Sales and Spare Parts. I jotted down a bit. The deceased has been identified as 32-year-old part-time body work mechanic of the company, Ramraj Palakadari, right? Palakadari was a resident of Block 20, Hasselton, ECD. According to the report, Palakadari usually arrives early at work and is tasked with repairing, renovating, and displaying the vehicles sold by the company. I'm going to try to jot down a bit, right? While he was doing so, the arm came in contact with a magnetic field of the nearby electrical wire, causing a 13,800 volts. He's dead. But he dead, right? But there's a way to calculate how much current that is, right? And in fact, folks, if you want, could you look at your book? Page 78 have the effects of current on the body. You want to watch page 79? Sorry, I say 70, but my mistake, page 79. Look, I have my chart here. So we'll kind of line up, right? So in 2 to 10 milliamps, your body is going to get a painful sensation. 10 to 25 milliamps is the inability to let go. Now, watch my hair bit. Now, I don't have time to show you all the maths. No is the maths part of this course, right? But you see this here? This is our normal sockets in Trinidad and in Guyana. That's like 110. 110 will give you that range. And even the 220 will give you that range as well, right? So if you see 25 to 80 milliamps, loss of consciousness from heart or respiratory failure. But look at the voltage here, 110 to 220. But watch how much volts. I'll try to show you. Watch how much volt you say went through this person. Not 220, 13,800 volts. So if 220 causing you loss of consciousness, there's a way to calculate it, like from the voltage, if you use the same formula, V is equal to IR, you could actually find the value here. You see this in milliamps, you could actually find that. You could actually convert this into this. You could calculate this 10 to 25 then, right? What I was telling you, I think somebody went and tried to get him, and that person, they said this, as a result, he sustained burns on his hand, torso, and feet. He was attired in regular clothing and slippers at the time. Upon observation of the incident, business proprietor of the SC Auto Sales and Spare Parts, Mr. Edwaru, attempted to remove the deceased from the vehicle. However, he received an electrical shock and had to be taken to receive medical attention. The person who tried to remove him, remember, you can't do that. Remember, we spoke about arcing and stuff too. You could move the person and everybody said that high voltage. And at high voltage, the current is going to arc onto the other person. You can move him, but you have to use a non-conductor, like a piece of wood, right? Like a piece of PVC pipe, right? But the other person got electrocuted as well. If you want, as I on it, now let me just share it with I'll forward it to the group chat. Because we have students. I have two students in Guyana here, don't I? Right? And then, like I said, these things happen anyway, right? I forwarded to the group chat there anyway, right? Ah, look at the time. I think we could wrap up if I could trust you all to read out the rest because I want to do one. There's no more exam question here, right? There's no more exam question here. The question was on current flow and stuff, right? So if you could read this out, right? We could move on to, let me see if there's a question here. Planning for power outages. You could use a generator or an inverter. I don't know if you all know what those, but an inverter, they sell inverters. You can get a small inverter. I have one. If you give me a minute, I'll show you the one I have, right? I have one in the room. Yeah. Look how small this one is. Look at this inverter that I have. This is an inverter. I have two. I have a digital one. The digital one remains plugged on and it charges then. So like when power goes, you can plug into it and you can get power. This one, you have to connect this to like a battery, like a car battery, right? I have actually done it. It will actually run down the battery of the car, but I have a spare battery, right? So because of that, I mean, folks in Guyana might not quite, I mean, but Guyana has power outages as well. But on the islands, then we do have bad weather. Trinidad, not so much, but I do have two inverters, right? That in the case of a power outage, I could connect this to a battery. I get full power with it. I get fans, I get TV. If it's the car battery, if it's like a vehicle, like a battery from a vehicle, then right when the battery runs down, all you have to do is start your vehicle with another battery, of course, as I have a spare one, and then you put in back that battery in it, and then the alternator would charge back the battery, right? So if you're planning for power outages, you can try to get an inverter or as well as a generator, right? I don't like the generators too much because they create carbon monoxide. And the carbon monoxide, as I mentioned with the story there, is an asphyxiant. It would displace oxygen and it could result in you going to sleep then and not waking up back anyway, right? So they are called uninterruptible power supplies like generators are only reliable as the maintenance that is performed on them. For example, most systems use lead acid batteries, right? So you can read this out. I don't think there's a question here. This is all about planning for power outages, generators, and backup systems, right? So there's one here though. This I was trying to reach, right? So there's one here. There's a common question here. Like we said, there are things that is sure to come, right? Like for example, what is process safety? The PDCA cycle is common. If you want, you could line this up with around page 84 and stuff. But I would have these zoned down in the question because it's about 18 minutes past 2. So I'll read one or two and I'll zone down in the question, right? Like I was saying, everything have a question. Bow tie maybe a question, right? But this one here, like how we did today we did steam. There's going to be a question on steam. There's a question on nitrogen. This is a common question here, right? Let's just read. I'm going to read about 3 slides and then I'll zone on the question, right? Based on the time. So if you look at your book, they have dangerous substances, the same thing here. What is a dangerous substance? A dangerous substances and explosive atmospheres regulation. They have a law for it, DISA for short, defines a dangerous substance as a substance or preparation which is explosive, oxidizing, extremely flammable, highly flammable, or flammable. That's not the exam question, right? I'm moving on. So I'll just read one more. Another definition for a dangerous substance is substances of preparation which, because of its chemical properties, the way it is used or present in the workplace, creates a risk of explosion or fire. All right, and all of these are, like what a dangerous substance is. It's very toxic, it's oxidizing, it's flammable, highly flammable, extremely flammable. So that's not the exam question either, but this is the exam question. So let me explain it here a bit, right? Let me explain it a bit. So here the thing, right? The same law, and you're looking at here, COMA, this is a law from chapter 2. The Control of Major Accident Hazard Regulation had required the company to have a MAP policy. Anyway, long story short, that law requires the employer to categorize the areas that a worker is working in if they are exposed to a dangerous substance. They call it zoning. They require the employer to zone the area, right? Let me see how best I can do this in a short period of time. So in the world today, there are two types of zones that I use. There's a classification for gases, and there's a classification for dust, right? There are two types of zoning numbers that I use then. So there's a zone classification for where you have gases, and there's a zone classification for where you have dust. Quickly, the zone classification for gases is 0, 1, and 2. And the zone classification for dust is on the other slide. But as I write it already, I'll write it here for you. It's 20, 21, and 22. I'm going full steam ahead, right? So the next thing here is that the zones, like if what zone 0 means, zone 0 means the worker is working in the hazardous atmosphere. Watch it here. It is present, right? The gas is present. The worker is working where the gas is present, right? So that's zone 0. Zone 1 is the worker is working where the gas is likely to be present. Where the gas is likely to be present is classed as zone 1. And zone 2, where the worker is at, the gas is not present. It's like an office worker there. Or you may be in a building in a remote location. It's your company, right? They're dealing in nitrogen or some kind of gas, ammonia, whatever, right? Of course, ammonia is very common in Trinidad, but you may be exposed to another type of gas then, right? But if you're in zone 2, it means that you are not exposed to that gas. You are in a safe base, right? So you are in an offset location or offsite location, but the gas is not likely to be present there. I'll give you a simple example, Justin. Let us run through the theory and I'll break it down for you just now, just simple example, right? For dust, zone 20 is that you are working in a dusty environment. So you are working in the cement company. You are where they're making the cement, concrete, if I said cement, right? Or concrete mixture or aggregate. You are working where the dust is present. If you're in a fabrication shop or in the iron and steel business or the gold mining business where it have all the dust, you are working there. They call that zone 20, right? The same thing happens here. So I just put L for likely. If you are close to the dust, right? But you're not in it. They say you are likely to be exposed. And then the unlikely or the not likely is zone 22 for dust. So before we go any further, you only could imagine that you have to learn these numbers because again, it's not an open book exam, right? So you have to learn these numbers for gases and for dust. It comes in every sitting, and in some sitting you get the two questions. Some sittings you get gas or dust. Some sittings they hit you with gas and dust. Like you get like number 16 is on gas and number 17 is on dust. So you have something to learn here, right? 0, 1, and 2. You see how NEBOSH process safety is higher than the certificate level? We never learned nothing like this on the cert level. This is in the diploma level though, right? That's why I like process safety. Process safety introduces you to all of these things, right? So I'll say it again. It's 23 minutes past 2. I think I'll stop here, but I'll show you a question, right? I'll show you a question, but you have to learn these numbers. Gases is 0, 1, and 2. Dust 20, 21, 22, right? And before we go to the question, let me just give you an example here, right? So watch my here with this example. Let's just take a gas station. So you may say, well, I have never been exposed to a gas. Yeah, but let's go to the gas station. So I join a pump here, right? This is one pump. These will be the vehicles and them coming in here, right? So because that's one pump, that's another pump here, right? And of course, there'll be like a quick shop area inside here. You can pick up your little drinks, phone cards, little groceries and stuff inside it, right? The cashier is here. Now, this may look silly, right? But this became for a question. That's why I'm using this, right? So the gas station, of course, in Guyana has many different gas stations, right? You have anybody can help me with it. You have Shell, right? You have I think Green Sol. Or Sol is a gas station, not really Green Sol. Sol is a gas station. You have many different gas stations, which I admire in Guyana. Trinidad just have one main entity or two, Unipet and NP. but you have many suppliers of gasoline, many different gas stations. You have Shell, of course, you have Sol, Guyana Oil, I think, or Guyana something, Guy something. Can't remember what it was, Guy. Can't remember what it was, right? Anyway, the point is this, right? So this was a NEBOSH question. If the pump attendant is here, right? The pump attendant is here. What type of atmosphere would that be? What zone would you put that pump attendant in? And if the office worker or the cashier is inside here, or you are inside here, what type of atmosphere would you put this person in? The first thing to ask yourself, right, is what type of numbers you're using. Is it gas or dust we're using? This is a gas station. So is it gas or dust we're talking about?
Yes.
Gas, right? So forget 2021 and 22. That's one of the things. We might have multiple choice. I'll show you one just now. If you know it's gas they're talking about, well, anything with 2021 and 22, that's wrong, right? So the pump attendant, what type of atmosphere would you put him in? Like 0, 1, or 2? What type of zone would you put him in? It's not going to be 2. So it's going to be what?
Zero.
Probably 0 or 1,
Zero,
right?
one.
Now, yeah, so the past paper will actually tell you, or the future paper will actually tell you which is which. They'll give you a hint. They will give you a hint then as to which it is, if it's 0, 1. I'd probably say zone 0 for now, right? Inside here, if you are in here, um, if you were in here, right, what would it be? What?
That might be a 2, because those
That might be
buildings are usually sealed off.
right, very good. That'll be a 2, right? So it's like this. It's not too hard. Let's take a look at a past paper and you'll see what I mean. By the way, your book have one. I don't know, the book, the same questions on the slide is the questions in the book. And you want to watch it from the book or you want to watch it in the slide? If you have your book, if you don't have the book, I'll have to line it up anyway. The kind of coordinating us take the extra time, right? Look, there's a question here, but the same question is in the textbook, right? So, um, exactly in chapter 4, they have it though. But we have it right here on this slide, right? Those of us in the book, they have it in, I lost it. I probably lost it, didn't I? No, they have it on page 127. But it's a different, no, it's the same question. It's the same question. Yeah, it's the same question. Page 127 in your textbook is the same question. It is repeating at different times and stuff, right? So they say, which of the following is a zone 1 classification? So already you're supposed to be thinking gas, right? And if you study your work, you're supposed to be thinking gas and which one? Likely. So you just watch it for the answer and you're shading or you're taking that on the exam paper and you're moving on, right? So which of the following is a zone 1? A place in which an explosive mixture in the form of a cloud of combustible dust. When I read dust, I will forget that one time because remember, zone 1 is what? Zone 1 deals with what? Dust or gas?
Gas.
Right.
Yes.
So when I see dust, I know that answer wrong long time, right? So I'm moving on. So A is wrong. B, a place in which an explosive atmosphere in the form of a cloud of combustible gas. Okay, well, this sounds correct. In air is likely to occur. So then B is correct. But let's just check the rest, right? A place in which an explosive atmosphere in the form of a cloud of combustible dust. No, if it's zone 1, it's not dust. Look my thing here. And then D, a place in which an explosive atmosphere in the form of combustible gas in the air is not likely. No, not likely is 2, not 1. So the answer is B. So you see what I do for you all, folks? I slow down, I teach, I show you all. You all just have to study. We can't guarantee everything, but we try our best to prepare you for what is what. And different papers are different. Some sittings will test dust, some sittings will test gas. You have to learn it, and that's why I wanted to reach it because the things to commit to memory is going to take a longer time for you to learn now. 0, 1, 2, 2022, 2021, 22. You have to kind of learn these things anyway, right? All right, let me get it rolled. We are done for today with 1 minute to go. Let me stop the recording. We just had 11 persons on, so I would have to, but I normally do post